All right, now here are a whole bunch of slides showing that the problem is bad and it's happening now. So if you thought you were going to stop watching these videos thinking, yeah, we can put off responding, I don't think so. Let's start with this quote. Global warming is contributing to an increased incidence of extreme weather because the environment in which all storms form has changed from human activities. A guy from the National Center for Atmospheric Research. Here's the linkage now between the climate crisis and the increased frequency and severity of extreme weather events. The news isn't just making this up. There are lots of new records being set, lots more powerful storms happening, lots more things happening because of climate change and global warming gases. Again, 2,000 years of concentration of CO2 in the temperature. Again, we're doing it. We're heating up the atmosphere. Come on. The global ocean heat content. Look at that. Again, it is bad. But check this out. Speaking of the global ocean. This is the sea surface temperature anomaly chart. Blue is cooler than normal. Red is hotter than normal. Warmer than normal temperatures in the ocean. October 29th, 2012. Kinda really hot around here. Anybody remember what happened on October 29th, 2012? That was Superstorm Sandy. Big hurricane. Swamped a lot of New Jersey, swamped a lot of New York City. Hadn't happened as far back as I can remember in Amal. As far back as pretty much anybody could remember. Check it out. Hot, hot, hot. Around New Jersey. It wasn't Chris Christie's fault. Trust me. Well, maybe it was. We'd love to be able to blame him after what he did with the bridge, right? Now, little fact, with each additional 1 degree Celsius, 1.8 degrees Fahrenheit of temperature, the atmosphere's capacity to hold water vapor increases by 7%. Like I mentioned before, water vapor itself can trap heat in the atmosphere. There's already 4% more water vapor over the oceans than there was only 30 years ago. Hence, there's a lot more water to dump out when it's time for a storm. Numbers about the extent of Arctic sea ice. New record low. Forget about it. The Arctic sea ice, I don't know. Maybe melting, rising sea levels. Bad. Arctic temperatures, same thing up in the Arctic. Temperatures are popping up now after 2,000 years of sort of steady, slow downward trend. That's up near the North Pole, the Arctic. Whoa, wait a minute. This was the proxy temperature record. This was the stuff that we got from lake sediment, ice cores, tree rings, that sort of data. The red is actually the real numbers. It kind of matches the blue where they overlap, but right now you're seeing that the real numbers are pretty bad and getting worse. And I guess there's no sense recording the proxy numbers anymore when you have real data. The jet stream itself has changed. The dotted line is the way it used to be, and now it goes up and down, higher and lower. So you're going to get that, what did we have recently? It was called the Arctic vortex that came down and hit the Northeast. Boy, am I glad I moved from New York. Lovely California, folks. Move out here, it's going to be nice. Everybody's going to live out here when the rest of the world experiences severe events like this. This is called a derecho. This is kind of a time-lapse thing. From 2 p.m. to 12 p.m. on this day, this line of powerful storms moved 600 miles, so it's like 60 miles an hour, and it was powerful. And it also makes for an impressive slide, but people haven't seen things like this since modern meteorology had started. So, as global temperatures continue to increase, the Earth's water cycle intensifies even more, and that's just evidence of the water cycle intensifying. You get bigger, harder downpours simultaneously, you get longer and deeper droughts, and here's 6 steps. More evaporation gives you more it gives you more warmer air, which let's start that again. Evaporation from the ocean into the atmosphere increases even more. And then as the increase of the temperature even more is what that I should say there. And as the air gets even warmer, it can hold more water vapor, and then you get heavier downpours because there's more water vapor to drop out of the sky when the storms start. Snowpacks melt earlier in the year, and then there are longer intervals in drought-stricken areas between downpours. So you have longer droughts with almost too much relief all at once. And more water also evaporates more quickly from the soil, making the droughts deeper and worse still, longer still. So, all right. Yuck. Have you seen cracked earth? I could have showed you lots of pictures of cracked earth, more disaster porn. But let's stick to the graphs and numbers. August 21st, 2012. The reds, the dark colors, extreme severe drought. Exceptional drought in the really darkest areas here. Exceptional. What else? What do we have for the witnesses here? Here we go. All right. Disaster areas. There's only 3,000 counties in the United States. About half of them are declared disaster areas. Got that. I think I skipped one slide. 2013. A little bit different pattern, but still a lot of exceptional drought. All right, here's fun pictures, sort of. It's great when the old guys got up there with their cameras, John Muir, et cetera, you see beautiful, huge glaciers in Alaska. 1880, go back now, the glacier is just melted, it's retreated, not there. But he thought that was bad. Check this out. As the permafrost melts, you get gas deposits that were trapped underground in this really rich soil that's between the ice, that's below the ice, escaping through the meltwater that's on top of it. So what's bubbling up here is methane, natural gas. Now natural gas, if you don't burn it, and you just let it get up into the atmosphere, is, depending on the amount of time over which you're measuring the effect, from like 37 to 80 times more powerful per unit, per molecule, in causing global warming than carbon dioxide. So just letting these natural deposits of natural gas get up into the air, just because the ice is melting, it's just going to accelerate climate warming. A guy from Stanford University says, I think there's been an under-recognition of just how sensitive crops are to heat and how fast heat exposure is increasing. So let's move from the water back onto land and talk about crops. Current research indicates that every day, the temperatures go over about 84 degrees Fahrenheit, corn yields decline by a good fraction of a percent, about 0.7%. So by the end of the century, given the trends, the yields in our cornfields could decrease by 1/3 just because of the increase in temperature. And this is the sort of thing that is already affecting the price of food and availability of food. These spikes in the food prices are related to extreme climate events, and we could expect to see more, and we will see more even if we stop emitting greenhouse gases now, but the sooner we do, the sooner we can slow down the rate of increase of extreme climate events. So from Princeton, guy says, climate change is disrupting natural ecosystems in a way that is making life better for infectious diseases. Again, you mess with the ecosystem, and opportunistic bugs, in this case, will spread. Another effect to keep in mind. It's a real public health challenge. Now, this is a little, less serious than most infectious diseases, but allergies are going to be pretty bad. In the year 2000, we had 8,455 grams of pollen per cubic meter. In the year 2040, it's going to be about 3 times, less than 3 times that much. Much worse, your allergies. But let's talk about death. Okay? In China, this is the air pollution that's been associated with the industrial revolution of sorts in China has decreased life expectancy already by an average of 5.5 years in the north of the country. And I was hearing that the Chinese scientists, the Chinese doctors, are not being allowed to say this to the media anymore, but kids, young kids, are starting to get lung cancer. who never smoked. I think there was a girl as young as 9 who got lung cancer, living in one of the very polluted areas of China. And that is the end of the segment.